Hi everyone, welcome back. It's Professor Sebastian. We're on page 115 of our statistics class notes, and we're in section 8.1 where we're getting introduced to the idea of hypothesis testing. So on the previous page we talked about there are 4 steps, right? We want to hypothesize, then we want to, let's look at them while I'm talking, then we want to prepare, then we want to do compute to compare, and then we want to interpret. So what do I mean by that? So let's kind of go through a thought example. This is not a hypothesis test, but it's an idea of showing you the different pieces of it. So let's say a coin is spun on a flat surface. You hypothesize that it's more likely to come up tails because that side of the coin bulges out slightly compared to the head side. All right, so we make a hypothesis. We think, hey, this is going to come up tails more than it comes up heads. So you spin the coin 20 times and it comes up tails all 20 times. So what we're doing now is we're preparing, right? We're preparing how we're going to use our data. All right, so we're going to spin the coin 20 times and come up tails all 20 times. If it was truly equally likely that the coin landed on heads or tails after spinning, it would be very unusual to find 20 tails in 20 spins of a coin. It's so unusual that you would conclude your hypothesis that the coin is more likely to come up tails when spinning is correct. So we hypothesize, we stated a hypothesis that the coin is more likely to come up tails, and we test this against the neutral hypothesis that the coin is fair. So we're testing our hypothesis that the coin is more likely to come up tails against the idea of a fair coin, which is considered the neutral hypothesis. Then we prepare. We decide we're going to spin the coin 20 times. That's what we decide we're going to do to test it. And then we do our computations to compare. So we collect our data, and our data said, holy cow, we got 20 spins, and all of them resulted in tails. So we got 20 tails. We compare that to our neutral expectation. Now our neutral expectation, if the coin was fair, should be like 50-50, right? About 50% heads, 50% tails, but we got 100% tails. If the coin was not more likely to land on tails, you would expect about 50% of the spins, or about 10 spins, to result in tails. However, you got a result of 20 tails, or 100%, which is much greater than the expectation. So what we do is an interpretation. It says because it would be so unlikely to get 20 tails in 20 spins if the coin was equally likely to land on heads or tails when spun, in other words, a fair coin, that the coin is more likely to land on tails when it's spun. Okay, now I talked about them, but let's be a little bit more precise. We actually are always going to have a pair of hypotheses. So H sub 0 or H naught or H0, those are all, sometimes I'll say all 3 of those. But usually I'll say H naught. That just means the neutral hypothesis, the null, it's called the null hypothesis. That's sort of what we expect things to be if everything's information from the past is the same, if the coin is fair in that last example, etc. Just kind of the expectation of what you should get when testing something. Then the alternative hypothesis is something that we actually kind of make hypotheses that we believe our data is going to show us this because we think something funny is going on. Okay? Notice that the null hypothesis will always have an equal sign. That will be very important later, so keep track of that. The alternative hypothesis is, again, the statement about the population pattern we intend or hope to demonstrate is true, and we're always going to contain either a less than sign, a greater than sign, or a not equal sign. And remember, as we go forward, the hypotheses are always about population parameters. They are never about sample statistics. We're always hypothesizing about the population parameter.